So, example 23. The function f is defined by f such that x is mapped onto 6 minus 2 lots of the modulus of x plus 3. A sketch of the graph of the function is shown in the diagram. Well, I've not given you that, so you are going to have to do the sketch, then state the range of f, give a reason why f inverse does not exist, and solve the inequality f of x is greater than 5. So we've got to be able to sketch this first. And just like last time, the best thing to do is to build it up. So the first phase is to look at where to begin. It's quite a complex thing, but our first step, we start with an input value, and the first thing that's going to happen to it is we add 3. So we're going to start with the line y equals x plus 3. And that's fairly straightforward. Gradient 1, passing through 3. We know we're going to take the modulus of it, so that bit gets reflected. So we have y equals x plus 3 at the start, and this line here is y equals reflecting, so we change the sign, minus x minus 3, the negative of x plus 3. Having those two equations at the start really help. Okay, so the next thing we're going to do is so we've now done the modulus, and we're going to multiply the modulus function by negative 2. So this function here is going to get multiplied by negative 2. So f of x multiplied, well, let's just do multiply by 2 to start with. So we do it in steps. Multiply by 2 f of x. And hopefully we know that that is a stretch. Scale factor 2 in y direction, that's with x-axis invariant. It doesn't move. Invariant. Okay, so if we're multiplying by 2, all that's going to happen then is that the gradient, the x-axis point doesn't move. So that would have been, if that's 3, gradient 1, that would be minus 3. If I put y equals 0 in that, into here, if you put y equals 0 into here, this will come out as minus 3. Okay, so if the x-axis is invariant, this point over here will stay as minus 3, but it's going to stretch it, so it's going to be steeper. So instead of going through 3 here, it's going to go through 6. And over here, again, it's steeper. If we take the graph, the equation of the original line y equals x plus 3, multiply it by 2, we get y equals 2 lots of x plus 3. So that's 2x plus 6. The other half of the graph is y equals 2 lots of negative x minus 3. Multiply it by 2, we get minus 2x minus 6. Okay, next step is to change the sign. Right, so I've actually got a little bit ahead of myself up here. Yeah, we just multiplied by the 2 last time, so we're now going to deal with the minus sign. Okay, so if we deal with the minus sign, we've got a function in x transformed onto minus f of x. So change the sign, we reflect x, or in x-axis. The x-axis is invariant. So our graph over here is going to get reflected. So it's going to look like, still x-axis invariant, so it's going to go down like that. It was intersecting at -6, so it's now going to intersect at -6, and this point is still -3. The equation over here was 2x plus 6, so we've got to change that into a negative. So y equals the minus of 2x plus 6, the negative, so we get -2x minus 6. Then we go to the other equation, which was minus 2x minus 6 up there. So y equals the negative of -2x minus 6, which makes it 2x plus 6 for that equation. It's important to keep track of the equations as you go through. And now, although the 6 is written at the front, there is no difference between what we've got there and minus 2 modulus of x plus 3 plus 6. Yeah? Taking it and writing it at the front, we're still adding 6 onto the expression. Okay, it's just a different way of writing it. So we should know f of x onto a plus f of x, or f of x plus a, it doesn't matter, is a translation. It's outside the function, so it's moving it in the vertical direction, a, and 0 sideways. So we are adding on 6. So the key thing here, if we move each one of these points up 6, we're going to end up with our v crossing. So this point here will be -3, and it's being moved up from the x-axis by 6. And our y-intercept is now going through the origin, because it's also being moved from -6 up 6 to 0. So equation of our line was y equals -2x minus 6, but we've added 6 to it, so it's y equal -2x. And here we've got y equals 2x plus 6, and we're also adding 6 to that, so we get y equals 2x plus 12. So we've got the equation of each line, the point of intersection with the vertex, the highest point, -3, 6. We've also got the one of the intercepts. We also probably should label this one. So that occurs when y equals 0. So at y equals 0, naught equals 2x plus 12, x equals -6. So we can label that in there. And that pretty much completes our sketch. So state the range of f of x. Well, the range is the output values. So A, output values, f of x, if you like, our y-axis, or f of x. This was our input values, x, and our output values have got to be less than 6. So f of x is less than or equal to 6, and f of x is a member of the set of reals. Range. Part B. Give a reason why f inverse does not exist. So it's not a one-to-one function. So if put in particular inputs, say here, we could go across, that would be our output, but there is 2 ways of getting that output. If we start here and we want to go back to where we started, we don't know which of the 2 points to go to. And as a result, we haven't got an inverse function. And we express that simply as saying, not a one-to-one function, therefore has no inverse. Part C. Solve the inequality f of x is greater than 5. So greater than 5, we need to put in the line y equals 5, and the section that we then want is in here because the graph is above 5. So we can look for the points of intersection by solving the two equations. 2x plus 12, which is the equation for this line, is equal to 5. So 2x equals negative 7, x equals negative 7 over 2. Here, y equals minus 2x on the right hand side, so we've got the equation of this line, y equals negative 2x, and at this point it must equal 5. So negative 2x equals 5, x equals negative 5 over 2. So therefore, f of x is greater than 5 when minus 7 over 2 is less than x is less than negative 5 over 2, because we want the bit between the two solutions. We want the section between the two solutions that we got. And be careful of the inequality. This was greater than, so these need to be strictly greater than or strictly less than signs. Have we finished everything? Let's check. Yes.